Okay, hello everybody. Let's go ahead and take a look at surface area and nets. What we're going to first start off with is a net. What is a net? A net is a connected two-dimensional layout of all the faces of a three-dimensional object. And the three-dimensional object is usually called a prism. So let's go ahead and see how we can actually go ahead and create a net based upon a particular three-dimensional object. In this case, a triangular prism. Now again, why is this called a triangular prism? Well, we have a three-dimensional object, and the sides that are containing the three-dimensional object itself is going to be a triangle. So we call it a triangular prism. Now, in order for us to go ahead and visually think about how to create a net, what we have to think about is something very similar to, say for example, a transformer that we're all familiar with in the movies. Basically, you have this shape that all of a sudden just becomes something else, right? It has all these parts that move and it becomes something else. When we actually go ahead and determine what a net is of a three-dimensional object or a prism, is we got to think about it in the same respect. So here we have this triangular prism, and basically what it's going to do, it's going to unfold itself so that it becomes two-dimensional, and all the faces become flat on a two-dimensional surface. So basically what's happening here, hopefully you can see this, is that it's actually opening itself up like this, and then the two triangle sides are coming down like this, so that it's flat on the surface. Now if you can't see that, then another way to also think about it is take a look at this, which is the representation of the net of this triangular prism, and imagine it kind of rolling back together and become a three-dimensional shape. And hopefully you can see how this side here would just, once these flaps come up like this part would come like this, and then this part would come like that. And it would create the triangular prism. So that's what we're going to have to do, is we're going to have to become familiar with how to actually create these triangular prisms. Now, we'll do a lot of practice of this in class, but for the sake of moving on in this presentation, let's say that we're okay with creating triangular prisms, and in addition to that, making sure that we can also label all the sides so that they're appropriate and accurate and precise to this particular three-dimensional object that we started with. So notice that I have 1 centimeter here, that's this length, 1 centimeter here, that's that length, 1 centimeter there. This of course is 3 centimeters, 3 centimeters, 3 centimeters, 3 centimeters. This triangle is going to be exactly the same shape as that triangle over there. And the only piece that we're missing is x, which is represented by the hypotenuse of the right triangle. Now, how do nets relate to surface area? Well, let's go ahead and start off with our definition. The surface area is the sum of the areas of all the faces of a prism. So notice that what the net does for us in a two-dimensional format, it shows us all of the shapes that are part of the original prism. And so when we actually go ahead and take a look at the initial statement for surface area, basically it is the sum of all the areas of the faces of the net. Okay, so let's go ahead and solve this particular problem using the net that we've drawn. So what we can say then is that, well, if it's the sum of all the faces, area of all the faces, well, how many faces do we have? Well, we have 1, 2, 3, 4, and 5 faces of this triangular prism. So what I'm going to do then is I'm just going to simply state that we're going to add up a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5, knowing that this is representing a sub 1, which is the area of the rectangle, etc. So a sub 1 is the area of a rectangle with a base of 1 centimeter and height of 3. 2 is going to have exactly the same dimensions. 3 is going to be 3 times it by x, which is another area of a rectangle. 4 is going to be the area of a triangle, which is 1/2 base times height, in this case 1 and 1. And 5 is going to be exactly the same shape as well, or the same area. So what we need to do now in order to finish this is we need to figure out again what x is. So again on the side, how are we going to figure out what x is? In this particular case, it's very difficult for us to see what x is and how we can actually determine what it is. But when we refer back to our triangular prism, well, we know that that's going to be the hypotenuse of the triangle. So that means then that we can use Pythagorean's theorem to go ahead and determine what the value of x is, And notice that what we have here in our initial statement is Pythagoras' theorem. So we have a squared plus b squared equals c squared. We know that the sides of the triangle are 1, or the legs of the triangle have measures 1 and 1. The hypotenuse is x. So we know that 1 plus 1 is equal to x squared, 2 is equal to x squared. Take the square root of both sides, and we come up with x being equal to the square root of 2. So now we can substitute that back here, okay, because we didn't know what x was, but we can substitute that, simplify these values as well, and we come up with 3 plus 3 is 6, plus 3 times the square root of 2, plus 1, which is 1/2. We can add the 6 and the 1 to come up with 7, plus 3 square root of 2 centimeters squared. Okay, and so there you go. And if we wanted to go ahead and find the approximate value for that, just substitute that into it, put that into our calculator, come up with 11.2 square centimeters. So the surface area is approximately 11.2 square centimeters of this particular triangular prism. Okay, so let's go ahead and summarize. First of all, we'll go ahead and take a look at a net. Again, remember that a net is basically all the faces of a particular prism laid out in a two-dimensional form. Okay, and remember that idea of transformers. Okay, and then what we can do then is we can label all of those particular areas with numbers, because if we want to go ahead then and calculate the surface area of a particular prism, we just need to go ahead and add all the areas of the faces of the net that's laid out for us. We can go ahead and simplify and come up with the surface area and make sure that it is in square centimeters, because again, we're measuring area. Okay, so we'll take a look at some of these. We'll also, of course, practice how to draw some of the nets that we have for particular prisms, and we'll see if we can determine what the surface area is for those prisms. Okay, so we'll take questions during class, and let's see how you do. See you later. Bye-bye.